Level 3. Now we're getting somewhere. Now they're starting to get harder. Let's see what we got here. Well, I want you guys to notice, right off the bat, you probably noticed that 5 right there, that 5's not a perfect square. So I am really doubting that this whole thing right here, there's no way that that's a perfect square. But, well, let's try and do our normal stuff, see what we can do, right? So this is definitely looking pretty bad. Not only that 21's not a perfect square either. Not that that mattered, but hey, it would have been nice. So let's see what we can do. So, I'm going to take that x squared, put it in, and what do I get? Well, I get, on the outside, like normal, I get x and x. And then I'm going to take that 6x, and of course we're going to divide it into 2 equal pieces. So we get 3x and 3x. So on the outside, in order to get that 3x, what did we have to multiply it by? Well, we had to multiply it by 3, positive 3. Okay, and so finally in that last square, we should get 3 times 3, or 9. Let's check and see how we did. Was that a perfect square? Well, x squared's taken care of. Yep. 3x plus 3x is 6x. Yep. Whoops. I should probably be checking things off when I'm saying yep. Otherwise, I'm just kind of like talking to myself like I'm doing now. Now I'm going to take that 9 and that... oh, no, it doesn't equal 5. I really would like it to equal 5. Well, what do I do? Well, honestly, let's just cheat. You know what? Let's just cheat. I say let's just cheat. Here's what I'm going to do. I'm going to just make it 5. That's right. I'm going to just cheat. So I'm going to say x squared plus 6x. Instead of that being 5, I'm going to make it, I don't want it to be 5. I'm going to just make it 9. Well, I can't really do that. That really is cheating. I'm really not allowed to do that. So what could I do mathematically to make that work? I really wanted that 5 to be a 9. So I can't just cheat. I can't just make it a 9, right? Because I'm changing things. But we have that property, the addition property of equality, where we can add the same thing to both sides. So if I added, right, let's just kind of go back for a second. What did I do to get that 9? Well, I took 5 and I added to it 4. So in other words, if I take 21 and I add 4, then that addition property of equality says these two sides are still equal. They are still equal quantities because I added the same numbers to both sides. So in other words, I get x squared plus 6x plus 9 equals 25. And guess what? We know that that is a perfect square. How do we know? Well, because it's right there. We just said it. Come on, pay attention. So what is this? This is just a level 1 problem in disguise, right? In disguise, right? Because this is just x plus 3, quantity squared, equals 25. So we're thinking of something. Squared equals 20 equals 25. So that has to be 5 or negative 5. So I get x plus 3 equals 5 or negative 5, which means... Whoops. Which means, what does that mean? Well, I'm running out of room. That's what it means. So what do we get? I'm going to have to cheat. This is really bad. This is so bad. I feel really bad. But 5 minus 3 is, let's do it in red so you could totally see this. So 5 minus 3 is 2. Negative 5 minus 3 is negative 8. So x equals 2 or negative 8. Okay, so that was kind of cool, right? We were able to cheat and still get it right. And again, it's not cheating. I know I keep on saying cheating, but it's not cheating. We used mathematics to our advantage. We were able to use the addition property of equality to our advantage to make it work. So let's try another one. Let's see. How about x squared plus 8x plus 15 equals 80. Okay, let's see what we can do. Why don't you pause the video and you try. Okay, I'm assuming you paused the video and you tried, so let's see what we can do. So first thing right off bat, well, let's see what we can do. I'm going to put this in a nice square. There's my nice square. Well, that's not a square, it's a rectangle, but pretend it's a square. So I'm going to say not drawn to scale, just like it says on the SAT. So we're going to take that x squared, I'm going to put it in my first box, and of course that was x times x equals x squared. And then I'm going to take that 8x and I'm going to divide it into 2 parts, so 4x and 4x. And what did I do to get that? Well, that had to be positive 4 and positive 4. So in the last box I should get 16, but I have, well, okay, let's check. Did it work? Did it work? Well, this x squared takes care of this x squared. 4x plus 4x equals 8x. 16 does not equal 15. It didn't work, but we're going to use math to help us out. So we're going to do a rewrite on this thing. So let's do our rewrite. So I'm going to change that 15 to 16 by adding 1. So, but of course, whatever I do to one side, I have to keep it balanced, so I have to add 1 to the other side. So now, this left-hand side, guess what? It's a perfect square. We know that for a fact, right? We already showed it in the box. So now we can say x plus 4 quantity squared equals 81, which means something squared equals 1, 81, which means those things are equal to 9 or negative 9. So x plus 4 equals 9 or negative 9. Subtracting 4 from everything, I get x equals 5 or negative 13. Pretty darn cool. Pretty darn cool. Should we do another one? Why not? Let's do another one. Let's just do another one. Let's see how it works. I don't actually have another easily ready, so let's see how this one goes. So I'm going to take x squared plus 6x plus 11 and set that equal to 27. So why don't you guys give it a go? Okay, hopefully you've given it a go. Let's see what we got here. So I'm going to take the x squared, put it in my box, and in order to get that, I had to get x times x. I'm going to take that 6x, divide it into 2 pieces, equal pieces. I get 3x and 3x. So in other words, this had to be plus 3 and plus 3. 3 times 3 is 9. Going through and doing my check. Well, x squared, perfect. 3x plus 3x is 6x, perfect. 9 doesn't equal 11. Well, as we know, no big deal, right? In order to make 11 9, what do I have to do? Well, I have to subtract 2 from it, right? So in other words, I'm going to subtract 2 from both sides. So this side, subtracting 2, gives me 9. This side, subtracting 2, gives me 25. Ooh, that's a nice problem, right? Because what is this left-hand side? It is a level 1 problem, which is just x plus 3 quantity squared equals 25. This problem looks really familiar. I wonder if we've already done it. I don't know. I'm just actually I'm really not sure. So something squared equals 25, which means that something has to equal 5 or negative 5, and that something is x plus 3. So solving, we get x equals 2 or negative 8. Now, we are next, in the next video, we are going to take on as hard as these possibly can go. We are going to go to level 4, and level 4 is really, that's as hard as it can go. So we're going to do some crazy stuff for the next one. So I'll see you then.